Hello everyone. Today we will be discussing the quick solutions of All India Akash Test Series JEE Main 2019 Test 7 Code E and F Mathematics, which was held on 3rd March 2019. Let us start with the question number 61, which says that if fx is greater than or equal to 0, x belongs from 0 to 1 and the area of the region bounded by the curve y equal to fx, x equal to 0, x equal to b, and the x-axis is b square minus 2b cube upon 3 for all b belonging from 0 to 1, then the maximum value of fx is, right? So here from the given statement we can say that it has been given to us that integration of fx dx from 0 to b is given to be equal to b square minus 2b cube upon 3. Now here if we differentiate it with respect to b, then on the left hand side we will get f of b, that will be equal to 2b minus 2 by 3 into 3b square, that will give me 2b square. Now substituting x instead of b, we will get fx equal to 2x minus 2x square. Now we have to find the maximum value of fx. So let us solve it by making it a perfect square. So taking minus 2 common, we can write it as x square minus x. Now if I add and subtract 1 by 4, so I will write it as plus 1 by 2. So this is equal to minus 2 into x minus half whole square plus 1 by 2. So from here we can see that the maximum value of fx will be 1 by 2. That will be obtained when x is equal to 1 by 2. So the correct answer will be option number 4. Next is question number 62, which says that limit of x tending to 0 sin x upon x whole raised to the power 1 upon 1 minus x into cot x. Firstly, let us observe that which form is this. Now, we can see that sin x upon x will tend to 1, and in the power, we can see that it is tan x upon tan x minus x, that is, it will be tending to infinity. So, this is 1 raised to the power infinity form. So, it can be written as e raised to the power limit x tending to 0, taking the power down, it can be written as 1 upon 1 minus x into cot x into 1 will be subtracted from sin x upon x. So it can be written as sin x upon x minus 1, right? This is the value of, let us say, I equal to this. So this is equal to e raised to the power limit x tending to 0 multiplying and dividing by tan x, we will get tan x upon tan x minus x, and here taking LCM we can write it as sin x minus x upon x, right? Now here let us observe the expansion of sin x and tan x, that is sin x is equal to x minus x cube upon 3 factorial plus x5 upon 5 factorial and so on. Similarly, tan x can be written equal to x plus x cube upon 3 plus 2 by 15 into x5 and so on. Now, substituting these expansions, we can write I is equal to e raised to the power limit x tending to 0. Tan x can directly be written as x plus x cube by 3 plus 2 upon 15 into x5 and so on into sin x minus x can be written as minus x cube upon 3 factorial plus x5 upon 5 factorial and so on. And in the denominator we have tan x minus x, that is x cube upon 3 plus 2 upon 15 into x5 and so on into x. Now here cancelling x, here I will get 1, here it will be 2 and this will be 4. Similarly, cutting x cube in the numerator and denominator, here I will get x square, and here I will get 1, and here I will get x square, right? So solving this further, it can be written as e raised to the power limit x tending to 0. Here we have 1 plus x square upon 3 and so on into minus 1 upon 3 factorial plus x square upon 5 factorial and so on, and in the denominator I have 1 upon 3 plus 2 upon 15x square and so on. Now if I put the limit, that is x is tending to 0, these will get cancelled. So we are left with minus 1 upon 3 factorial upon 1 by 3. That will give me minus 1 upon 2. That is, it can be written as 1 upon under root e. Hence, that is the correct answer is option number 1. Next, let us discuss question number 63, which says that limit n tending to infinity, n into n plus 1 into n plus 2 into n plus 3 up to n plus 1 terms upon n raised to the power n plus 1 whole raised to the power 1 by n is equal to. Here it can be observed that in the numerator I have n plus 1 terms, and in the denominator also n have been multiplied n plus 1 times. So we can give n written in the denominator to each term that is written in the numerator, right? So let us firstly assume the given limit equal to L, and let us take log on both sides. So let us see what we'll get. We can write log L equal to log of this whole term, that is 1 by n in the power can be taken out. So it is equal to limit n tending to infinity 1 by n into log of n upon n into n plus 1 upon n into n plus 2 upon n and so on up to n plus 1 terms. N plus 1 term will be n plus n upon n. Now this is equal to limit n tending to infinity 1 by n into, we know that log of a into b is equal to log a plus log b. So the given term can be written as log of n upon n plus log of n plus 1 upon n and so on up till log of 2n upon n. Now this is equal to limit n tending to infinity 1 by n into, this can be written as summation log r upon n, where r is going from n up till 2n. Right? Now here if I want to convert it into definite integral, then let us say I take r by n equal to x. Now when r is equal to n, then the value of x is 1, and when r is equal to 2n, value of x is 2. So this is equal to integral from 1 to 2 log of x into dx. Now we know that its integration by parts can be written equal to x into log x minus 1, and the limit is from 1 to 2. So this is equal to 2 into log 2 minus 1 minus 1 into log 1, that is 0 minus 1. So this can be written as plus 1, right? So this is equal to 2 into log 2 minus 2 plus 1. So this can be written equal to log of 4 upon e. So we can say that the value of L is equal to 4 upon e. That is given in option number 3. So it is the correct answer. Next is question number 64, which says that the line y equal to a divides equally the area of the region bounded by the curve y equal to 2x minus x square and the x-axis. Then the value of a is, let us try to make the graph of the given function. Let us say this is the x-axis and this is the y-axis. So the graph would be something like this, that is downward parabola, that is this point is 2, 0. So it has been given to us that here is some line, that is y equal to a, and it is dividing the area into two equal parts. That is, this area, let us say A1, is equal to this area, that is A2. Right? Now it can also be seen here that, let us say this is the line, that is x equal to 1. Right? So we can say that the area on the right of the line x equal to 1 is equal to area on the left of the line x equal to 1. So let us say that this area is A3 and this area is A4. Now here we have the condition that A3 is equal to A4. Let us firstly find the whole area, that is A3 plus A4. That will be equal to integration of 2x minus x square into dx when x is going from 0 to 1. So this will be equal to integral of 2x is 2x square upon 2. So it will be x square minus x cube upon 3. And the integral is going from 0 to 1. So this will be equal to 1 minus 1 by 3. That is equal to 2 by 3. Also, it has been given that this is the line y equal to a. So let us say this point is M. Right? So let us find the point M. Now, at y equal to a, we can say that x square minus 2x plus a is equal to 0. Hence, we can say that x is equal to 2 plus minus under root 4 minus 4a upon 2. So this is equal to 1 plus minus under root of 1 minus a. The 2 points are M and N. So the point M will be 1 minus under root 1 minus a, comma a. Right? Now to find the area A4, it will be equal to area of this small portion, that is equal to integration of 2x minus x square into dx from x equal to 0 to 1 minus under root 1 minus a plus area of this rectangle, that is equal to, this height is a into this length will be equal to 1 minus x1, that is 1 minus under root 1 minus a. Right? So solving this further, it will be equal to, its integral gives us x square minus x cube by 3. So we will get 1 minus under root 1 minus a whole square minus 1 minus under root 1 minus a upon 3, and here we have its cube. So 1 and minus 1 will get cancelled. So this will be equal to plus a into under root of 1 minus a. Now from this equation we can see that as A3 is equal to A4, so we can see that A4 is equal to 1 by 3. So putting it here, we get 1 by 3 is equal to this equation. Now here let us put under root 1 minus a equal to t. So solving this, we will get t cube equal to 1 by 2. That is, I can say that t raised to the power 6 is equal to 1 by 4. As we have to find the value of a, so from here we can see that as 1 minus a is equal to t square, so a will be equal to 1 minus t square, right? So from here, let us find the value of t square. Taking cube root on both sides, we will get t square is equal to 1 by 4 raised to the power 1 by 3. So we can see that a is equal to 1 minus 1 upon 4 raised to the power 1 by 3. That can be written equal to 1 minus 1 upon 2 raised to the power 2 by 3. So the correct answer is given in option number 2. Next is question number 65, which says that integration of 3 into sin x plus 2 cos x upon 3 into cos x plus 2 sin x into dx is equal to ax plus b times log of 3 cos x plus 2 sin x plus c. Then a plus 1 upon b is equal to. Now we know that how to solve these type of integrals. Let us see. What we do here is, let us write 3 into sin x plus 2 into cos x upon 3 cos x plus 2 into sin x equal to a into 3 cos x plus 2 sin x upon 3 cos x plus 2 sin x plus b times differentiation of the denominator. That is 3 into differentiation of cos x is minus sin x. So it can be written as minus 3 into sin x plus 2 into cos x. And in the denominator we have 3 cos x plus 2 times sin x. Now if I equate the coefficients of sin x and cos x, what will we get? 3 can be written equal to 2a minus 3b and 2 can be written equal to 3a plus 2b. Solving these two equations, we will get the values of a and b as a equal to 12 upon 13 and b is equal to minus 5 upon 13. Right? So substituting back in the given equation, we will get, let us say the integral is equal to I. We will get I is equal to 12 by 13 into integral of 1 into dx, that will be x, plus b, that is minus 5 by 13 into integral of, let us say this is t. So in the numerator we have dt, hence its integral will be ln of t. That is ln of 3 into cos x plus 2 into sin x plus constant. Now comparing this with the equation given in the question, we will find that a is equal to 12 upon 13 and b is equal to minus 5 upon 13. So we can say that the value of a plus 1 upon b will be equal to 12 upon 13 plus 1 upon minus 5 upon 13. Multiplying and dividing by 13, we will get 12 plus 13 upon minus 5, that will be equal to 25 upon minus 5, that is equal to minus 5. So from the given options, we can see that option 3 is the correct answer.